Okay, let's go on to Bhargavi's next question. I don't know how we are doing on time. I'm not tracking this. Okay, we are probably 1 hour, 1.5 hours into it. We'll have to speed up a bit. Given memory dump and no source code for an arbitrary program, you don't know what it does. How do you find the memory leak from this dump? Have you actually done it ever? It's not fun. Okay, so
I haven't done it, but I came across this question in class or somewhere. So I was just curious, like how to go.
Right. Okay. So when you say, so most of the time, so you're talking about memory leaks, right? Now, the two APIs that you use are Malloc and free. And if there is there could be memory leak because of many reasons, right? You may have problems of, basically not doing a free, or you may have actually done a free and then used the stale pointers and so on, or basically anything can be cause of this memory leak per se is because you're not freeing it. How do you detect memory leak? Now, if you have source code, you can instrument many things, right? If you have source code, you can instrument. For example, there is something called debug malloc, things like that. So basically what they will do, they keep track of the places where you allocate and give you a lot more information in the dump. The question basis of this question is you don't have source code. That means you basically cannot do instrumenting. So then what can you do? You can only do at runtime. Runtime, what are the options? So I'm not sure if which language you are talking about and so on. So let's say Java has a garbage collection. So the Java runtime can provide dumps, heap dumps, right? So the JVM, the Java virtual machine, has commands to trigger. So basically, tools like JMap to trigger dumps, and then you have JConsole, or I'm not sure, profiler. I'm not sure. These are some of the things that is provided by the Java virtual machine to deal with the dumps that can be generated from the Java runtime garbage collector. What do you do with this? If you have that, what information is available on the heap dump? Basically for the object instances, number of instances, size, and then references to other objects, and then references to this object. So basically keep track of these references so that the garbage collector can actually free it when their references are null, right? These are the information that is available. So what can you do in order to find a memory leakage is that, so remember, these are all snapshots. So snapshots of the all active objects at a given time. Active objects meaning live objects. So you take snapshots periodically, especially if you can reproduce the problem before the crash or whatever it is. And up to the point of crash, or if you have any other means to know from the logs when to take it. So you take it periodically, and then you compare the differences and then analyze that basically. So what kind of things that you will notice? Any abnormal increase in size of an object or in the number of instances. So suppose in a particular snapshot compared to previous snapshot. So basically you are seeing, for example, you have a singleton object and then you see more than one instance, then there is something suspicious there. Okay. This is one thing you will do. So basically you are left with nothing but doing things once periodically until the crash. That's all you can do. But there are tools available which can help you analyze, for example, the J profiler, so that you don't have to, reading that the dump is painful. So there are tools to analyze that. But all you can do is basically keep taking snapshots and comparing them. What you will compare for is any abnormalities in terms of size, number of instances, or you're not expected to have so many references to other objects or from other objects. So those are things you can do. There are many other details you can see as well. Now you can trace back probably from one snapshot to another to reconstruct the cause. Okay, that is a very painful thing, but that's all you can do. The other thing is, let's say we're not talking about Java. So other runtime we can talk about is the Linux, for example, which is language independent. So basically, Linux has, so mostly because of virtual memory, Linux has something called out of memory manager. Now, it is part of the kernel, it's say baked into the kernel. When a process requests for a resource, we are talking about memory, it allocates normally, but it basically may have basically we run out of resources, right? So it needs to know whether it can allocate, the allocation can fail. So it basically, this out of memory manager comes into picture when it runs out of memory. Even in virtual memory case, it can happen. So it does what is called womb kill. So it can kill another process in order to fulfill the request from this process. So it basically reclaims the resources by killing a process. And it has a sophisticated algorithm for selecting the process to kill. So what, in order to, so it has the algorithm for selecting, it ranks the processes in terms of their badness, in terms of resource usage. So something which I'm not familiar with the details, but it does that. So basically it can bump a process, and because it is considered the most ill-behaved process in terms of resource, it may be actually allocating a lot of memory and not using that much memory and so on. So this is possible in the Linux case, and it can kill that. So what your handle for debugging is basically to look at log files, kernel log files, right? So whenever it kills, there will be an entry in the log file, right? So you'll have this var log, and then the kernel log will be there. So if you grep through that and see if any, there is something called OM kill signature for a process that is killed, terminated process. You can do the PS awks and things like that. You can see which process has been killed and then try to see the circumstances leading to that, right? So this is one way of finding if a process was killed and then it was considered a bad process, then potentially it is not using the memory correctly. So usually the kernel will not do that aggressively. The killing as a last resort it will do, but it depends on the actual memory available, the swap memory, the virtual memory, whatever is basically the configuration of that Linux kernel there. You can also do other simple commands periodically. For example, there is something called the proc meminfo. It's basically a virtual file. So you can see this to see what kind of memory is being used by various processes. And then there is another command, I think, called vmstat. These are all to do with virtual memory, but it can be used. Then there is a tool called htop. Basically, this command will give based on a histogram of the top resource consuming processes. So by looking at these, even before the dump happened, you may be able to get an idea. It's just like if your desktop is slow, you do a PS and then see what process is using what cycles and so on, what percentage of CPU. It's just like that. So I can only think of these. So if it is a structured dump from a garbage collector like Java, there are tools to analyze. Even in Linux, you have tools. I think there's something called Valgrind, but I think this requires instrumentation. If you're not talking about instrumentation, you are left with the logs, kernel logs for any process which is terminated, or use these commands to monitor before anything got terminated. Yeah, Bhargavi, this is all I know about this question.
Yeah, thank you so much, Raghu. One clarification I wanted is, so this OOM, it kind of ranks and kills the processes, right? So wouldn't that reclaim the memory as well, or do you still think
that is the idea of killing, but it may not kill it. It is killing some other process, okay, not this process which is requesting. The whole idea is to provide the resource memory to this process.
Okay, but if that particular process is killed, then the possibility of the memory leak happening because of that process is like very minimal, right?
See, this is in the context of Linux. Now, if that process has nothing to do with this application, obviously this application can work well. But the question is, what happens to that application which was basically instantiated in that process? That is a different issue altogether. But the offending, it is assumed that OM can select offending processes which are the root cause for memory leaks or running out of resources, right? So it is basically allowing this to continue and killing only the worst behaving process. So now, obviously, there will be ramifications of killing a process, but that is another matter altogether.
Okay. Makes sense. Thank you.
Okay. Now, let's go to the next question again. Potential problems of using Malloc in a multi-threaded setting and assuming no data race or hardware issues. Is it performance degradation? I would say yes, but there could also be logical implications. I can think of one example. So the performance degradation, will come to that next. So that could be, let's say you have Malloc and it basically uses logs. to be thread safe. Right? Now, locks will basically mean malloc is not re-entrant. Right? So you cannot nest mallocs. When will malloc nest? Let's say you have an ISR or a signal handler in the case of Linux. They are asynchronously called and they can nest. Suppose you are using malloc from an ISR inside an ISR and it's nested. So the malloc get nested. The lock is already acquired by the malloc, and again you are trying to acquire this. It will basically stall the system. So it is not re-entrant because of that. And therefore you can have logical issues because of that. Even though you don't have data race condition across threads, you have a re-entrancy problem because it is using locks. I can think of this. So that's why it's not a good idea to ever use malloc inside an ISR. And definitely not, I would avoid using malloc per se, but not use malloc inside an ISR or a signal handler. And also basically anything that is not re-entrant, not just malloc. But since we are talking about malloc, I'm just emphasizing on that. So there is more to that than performance degradation. Okay. Now let's talk about performance degradation. So the standard malloc, I talked about the log. So the granularity of the log can vary. Okay. Now it's a coarse log. Obviously, lot of queuing happens at the log for acquiring the log, right? So basically that serialization happens by this queuing. And therefore multi-thread safety is achieved by this serialization. And if you have multiple threads and they do frequent memory, malloc, then this queue can build up. And obviously this can slow some of the threads and so on. So if you have a high priority thread doing a lot of malloc and then holding up for a long time, then it can actually basically delay or make the other threads tardy. That is the coarse grain. Now, there are other options also to malloc you could use to overcome this. I think in glibc, later newer versions, there is something called PT malloc. So what it does is it basically, instead of one single log, global log, it divides the memory into arenas and then log per arena. Arenas are smaller chunks of memory you can think of. And so the malloc, when it needs, it selects an arena and then allocates from that. Okay. Now the selection of an arena can take care of already locked arenas, and it can avoid that. So it can be a sophisticated. I think this PT malloc does a reasonable job of selecting an arena so no lock contention happens, and therefore it improves the performance over malloc. Of course, I also came across something called ned malloc, which is an alternative to PT malloc, but I'm not familiar with it. Okay. Yeah, Bhargavi, you have any further questions on this?
So this selection of this arena, so you mentioned that it could be already logged arena. Just that point I wanted.
No. Basically, it will avoid logged arenas. So you can choose something which is not logged, right? So you avoid contention for the log.
Got it.
Okay.
Yeah.
So basically you have multiple locks, it's like, in the file system or in the database, you can lock the whole file, or you can lock records and so on. So it's a matter of granularity of the lock. And Malloc by itself is a coarse grain, and PT Malloc is a moderate grain, I would say. Okay.
Okay.
So performance issue is one, and then remember that re-entrancy is a bigger issue.
Okay. Okay. Makes sense. Thank you.